Hello and welcome to today's class. Today we have this expression before us here. Okay, so we are familiar with some symbols in mathematics. We have what we call the factorial as a symbol. And if we decide or we go ahead to write, let's say 3 here, this is what we call 3 factorial. And 3 factorial means all we just put here is 3 times our 2 times our 1, right? And this will give us 6. Okay, so if we say factorial of 3, it means the number of times we can arrange 3 items. Okay, so yeah, it means we can arrange 3 items here in 6 different ways. In 6 different ways. All right, but now if you check this expression we have here now, we are having the factorial symbol at the back of the 6. Okay, but this is written at the front of it in this case, but here it is at the back. And so what we call this is what we call the subfactorial. Okay, so when we say the subfactorial of 6, what is the value? How do we find the value of the subfactorial of 6? Here we have expression for our subfactorial. For instance, if you have your x, okay, let's say you have your the subfactorial of our x. This is simply our x factorial bracket our 1 all over 0 factorial, then minus our 1 all over 1 factorial, then plus our 1 all over 2 factorial, then minus 1 all over 3 factorial, then plus this we go on that until we get to our plus 1 all over our x factorial. Okay, so this is the definition of our subfactorial, right? So now we are having a subfactorial of 6. How do we get the value of this? This is simple, right? So this is going to give us, let's take our selection here. So having known this expression already for our subfactorial, then we can say here the subfactorial of our 6 will now give us here our 6 factorial bracket our 1 all over 0 factorial, then minus 1 all over our 1 factorial, then plus 1 all over our 2 factorial, then minus 1 all over 3 factorial, then plus our 1 all over 4 factorial, then minus our 1 all over 5 factorial, then plus our 1 all over 6 factorial. Those brackets, because here we have the subfactorial of our 6. And so we stop at 6 here, okay, from our expression we had here, right? Okay, so what we do here is just to go ahead and look for the value of what is 0 factorial. 0 factorial is equal to 1. And so this is going to give us, let's keep this our 6 factorial in here. Do you know why? Because if you check this expression we had here from the definition of our subfactorial, we are having x factorial equal to, the last expression is going to give us 1 all over x factorial. And because of that, let's keep this 6 factorial here. And so we have 6 factorial bracket 1 all over 1, then minus 1 factorial is still the same thing as 1. So we have here 1, then plus our 2 factorial is 2, because that will give us 2 times 1. Then minus our 1 all over 3 factorial is 6. Then plus, here we have 4 factorial will give us 4 times 3, which is 12, times 2, which is what? 24, right? So here we have here 24, then minus our 1 all over. So our 5 factorial will give us 5 times 4, which is 20, 20 times 3, which is 60, 60 times 2 will give us 120. So here we have here 120, then plus 1 all over our 6 factorial. If we multiply out, that will give us 720, right? That's what we have here, 720, close bracket. All right, so from here we are having plus 1 all over 1 minus 1 all over 1. So this leaves the system. So let's keep our expression here, 6 factorial, right? Bracket here. We are left with 1 all over 2 minus 1 all over 6 plus 1 all over 24 minus 1 all over 120 plus 1 all over 720. So we just have to find the LCM of everything here. So the LCM is going to give us our 720, right? Good. So if we have 720, then we use these two to divide our 720, and 2 into 720, we start with 7, this will give us 3, right? Then carry 1 to this side to give us 12, so 2 into 12 will give us 6, then 2 into 0 will give us this. Then we come to this side here, we have 6. So how many times will 6 go into this? Then let's put in our sign here, minus 6 here, we have 1, then bring 1 here to give us 12, then 6 into 12 will give us 2, then we have 0 left here. How many times will 24 go into our 720? So let's erase this and still extend this. Okay, so here we have minus, we use 24 to divide this. This is going to 24 into 72 will give us 3. So into 0 will give us 30. Then plus, right? Oh, sorry, here we have plus here. Then this other side here, we have our minus here. Minus. Then how many times will 120 go into our 72? 0 will cancel out 0. So 12 into 72, that will give us 6 times. And so that will give us a 6, right? So we have 6 here. Then plus 720 into 720 will give us 1. All right. So let's close up here. So this is equal to 6 factorial bracket. Let's put our bracket sign here. So let's sum up everything here now. So we have 360 plus our 30, that will give us 390, plus 1 will give us 391, right? Then we have our 120 minus 120 minus 6 will give us minus 126. All right, so if we subtract, this is going to give us 11. So 5 from 6 from 11 will give us 5. Then, yeah, 2 from 8 will give us 6. And 1 from 3 will give us 2. So we have 265, right? So we have here 265, those brackets, all over 720. Okay, 720. Now, mind you, what is our 720? Our 720 is our 6 factorial. And so we have 6 factorial here. So this is equivalent to 720, right? Good. So this, okay, this and this will leave the system. So we are now left with this, which is equal to our 265. So therefore, the subfactorial of 6, we cannot say therefore the subfactorial of 6 is equal to 265. Okay, so this is the value of our subfactorial of 6. Okay, this is a simple one just to keep us abreast of what is happening here. All right, thank you for being there. We're going to bring more questions with regard to some of the symbols in mathematics. Okay, thank you. See you in our next class.